Hi, everybody, and welcome back. So last time we had talked about applying functions to vectors and then the overall philosophical purpose for the split apply combined strategy. And now what we're going to do is we're going to give an example of how we would use this in practice. So if we have gapminder data, which we do, uh, we would probably not want to apply the exact same analysis to every single country in the data set because you're mixing countries together that are very, very different. Like it doesn't make a whole lot of sense to perform the same kind of machine learning analysis on a country like Singapore as you would apply to Nicaragua. Okay, they're totally different parts of the world. They have totally different cultures, totally different natural resource patterns, totally different economic and geopolitical history and stability versus instability, all this kind of stuff. So you would want to say, okay, well, we're going to perform like this subgroup analysis, and we're going to split the data up by country. So there's thankfully a function to do that. You say, okay, well, I want to split up my Gapminder data and I want to, this is an expression, this tilde says we're going to be writing an expression, split it by country, okay? So what this is going to do is it's going to take, we've got like 128 countries or something, I don't remember, maybe 150 countries, who knows, whatever. Gapminder has a ton of countries in there. And so we're going to end up with a list of data for each country. Okay, so I'm going to show you the first three of them. So this is the first three countries. We've got Afghanistan and its own data set, 12 rows and 6 columns, then Albania, then Algeria. Okay, and if we wanted to look specifically at a country, I've got some friends from Cameroon. So we look specifically at the Cameroon data. All right. And here's what we can do though, because we're splitting up the data into an ordered collection of elements. So so if I make a list, this country's LS, each element of this list represents a country, and each element is a tibble of 12 rows and 6 columns. And they all have the exact same structure. So that means that I could write a function and say, okay, I've got a function that I want to use this function to perform some calculation on a country level data set that I know has 12 rows and 6 columns. And then I'll use the map function. So I've split up my data from this one giant data set, and then I've broken it up into this data set, then this data set, then this data set, then this data set, all the way down the line, all the way to Zaire and Zimbabwe or whatever. Then I would be able to perform an operation. Well, what's the operation I want to do? Maybe I want to find the maximum life expectancy. So I can do this on one country. I say, okay, give me Cameroon. So this is the data set for Cameroon. Now give me the life expectancy column and find its maximum. So in this time from 1952 to 2007, the maximum life expectancy was about 55 years old for Cameroon. Okay. So now that we've split our data, we can apply, this is the method that we want to apply. We want to find the maximum life expectancy. So here's what we do. We say, okay, let's map the data. First thing first, we need to extract the life expectancy. This is one operation. So operation one, go into the country's list and give me the life expectancy column. So now the output of this command, notice we're going to be doing and then, that pipe operator hasn't gone away. So this is going to be a list, and that list will be the life expectancy column for every single country in this ordered collection. And then I want to apply my numeric summary function to all of the life expectancy. So I'm going to have another list of all of the life expectancies. And what do we have here? Now I've got, for the first 5, I've got my numeric summary function, my 8-number summary of the life expectancy for Afghanistan, then the life expectancy for Albania, then the life expectancy for Algeria, Angola, Argentina, etc. So my first 5, okay? And we could probably get this similar thing doing group by and summarize. However, group by and summarize is restricted to what you can do. This is not. The split apply combine strategy works for anything at all, okay? Far beyond the capabilities of the summarize function. Okay, so what I want you to do is I want you to create a version. So here's another exercise. Do some more work on the summary function and apply it again to the life expectancy or to some column that you care about. So I'm going to pause here, let you work on that. Okay, so you've had some time to work on making modifications to the summary function, and we had these were the numeric summaries for each country across time. Now we want to combine them because right now we're in a list, but this doesn't help us very much because lists can be somewhat challenging to work with. However, we do know that for each country there are 8 numbers, and they're the same 8 numbers. So that means that we can combine these results. Okay, so we've got a list of the numeric summaries of life expectancy, and we can say that the elements of each vector are numeric. So we've got right here, we've got a named atomic vector right here, where here are the names, and we've got numeric information. So now what we can do is we can change this from a numeric vector, a named numeric vector, to a tibble. Okay, now this is the first step. So the first step is to change it from a numeric vector to a tibble. And we have a strategy for this because one of the functions that out of dplyr allows us to, if we have a whole bunch of tibbles, we can bind their rows together. Okay, so we'll get to that in just a second. So the bind rows function, if you don't give it a tibble, but if you give it just an atomic vector, what it will do is it will change your data from this atomic vector into a tibble of that same kind of information. It'll preserve the names as well. Okay, so the first thing that we're going to need to do, so we want to do this for everything. First thing we need to do is we need to map the bind rows function to turn every single one of these elements right here. These are currently numeric vectors, named numeric vectors. So the first step will be to change all of them individually into one row tibbles. And then once we have a whole bunch of one row tibbles, so that's right here, I've got a list of one row tibbles, then I can bind that list and add an ID column that I'm naming country. And now I get a record for each tibble, or for each country. And so I have a numeric, now I have a tibble where each row is a country and each column is one of the summary measurements for life expectancy for this country. Okay. Now, I don't know if you appreciate just how incredibly powerful this is, but you should. Okay. So this is where we're going to leave you with some exercises so we're going to pause here. You're going to work on these exercises. Spend 20 minutes or so getting through these exercises and then come back and continue this video. So we're going to pause here. All right, see you soon. Okay, so you've had some time to work on these exercises. I want to give you another example of how this split apply combine strategy is really, really flexible, really, really powerful. Earlier on in this lesson, I told you to go download some tornado data and put it on your computer in the data folder. So what we can do with this data, so inside of your data directory, now mine has an underscore, yours shouldn't have an underscore, yours should just be called data. There's a folder that you were supposed to call per example data in snake case. Inside of this folder, there's a whole bunch of there's a whole bunch of CSV data about tornadoes based on the year. So if I wanted to import this data set, import one data set at a time, I can use the readr command, read_CSV, and then I just need to specify what the file name is. I say, okay, well, give me this file name, the 2008 tornadoes data. Okay. Now, what if I had 100 or 1,000 of these data sets? I would not want to sit there and write 1,000 read_CSVs. That just does not sound like a fun time. But I know if I'm going to be doing the same task to an ordered set of elements, in this case, the ordered set of elements are CSV files, I can make a vector of these CSV files and apply or map the read function to import every single one of these CSV files into R, and then potentially combine the results. Okay. So that's what we're going to do. The first thing we need to do is we need to say, okay, I've got a whole bunch of files on my computer. I need to create a vector to point at where those files are. That's what the list files command does. So as long as you specify where the data sets are, so we've got our data sets right here, I say, give me all of the files in this directory and give me their full names. So the full names is actually the path on the computer to where this file is, and that's going to be this thing right here. That it's in the data directory, in the purrr or the data subdirectory, then the purrr example data subdirectory, and then a file, this CSV file right here. So the data paths is going to be all of these full names. And then what I'm going to do is I'm going to assign the names of this character vector. So using the names function as not the full names, but the actual just the files themselves, i.e. the 2008 tornado.csv, 2009 tornado.csv. So that's what this is doing right here. And then I can map it. Okay. So I have the data paths character, and I want this character vector of all the data paths on my computer. And the action that I would like to do to each of these paths is read CSV, import the data that lives in this location. Okay. And so this is where we're going to stop. These are exercises for you to do. I want you to repeat what we've done here. I want you to take a look at what's going on with this object before you assign the name. So take a look at the output of list files and then run this code and see what happens, what it looks like before and afterwards. One of the reasons that we want the names is because map will automatically assign names to the elements of our list based on the names of whatever this .x is. So that's also important here. So go through these examples right here and wrap your head around what's going on. Okay. And the reason for this is if I give you a access to a data warehouse or a data lake with hundreds or thousands of data files, and I say, I want you to import all of these into R, and I want you to clean them and wrangle them, then you shouldn't like pass out from fear. You should be like, oh, okay. If I can write code to clean and wrangle one of these data sets and they all have the same form, then all I have to do is import all of the data sets, apply this function to clean them, and then save the results. So you just have to write the function and make sure you test the function, make sure the function works. But you've got your import command that's importing all of these data sets, and then you're going to apply the cleaning command to all of the imported data sets, and then you saved the clean data sets onto your computer. I hope you realize just incredibly powerful that is, that you could save yourself weeks or months of effort by just spending a couple of hours writing some computer code. So anyway, that's where we're gonna leave off. The next lesson is going to be kind of putting everything together that we've learned so far to explore some data sets. Alrighty then. I hope that this lesson was helpful to you. I know that there's some very, very complex information here, but I hope you were able to learn. So we will see you next time.